Besides concrete and asphalt, what other material could build a truly sustainable road? For decades, the world believed that building a durable road required refined asphalt, solid concrete, and million-dollar budgets. But in one of India's poorest regions, a group of young engineers proved otherwise. They used nothing more than coconut husks, a common agricultural waste, to build roads that cost just 1/4,600 of a concrete highway, yet were so strong they left experts around the world speechless. So what makes this humble, overlooked material outperform modern infrastructure solutions? In this video, Massive Minds invites you to explore the journey behind these ultra-cheap, ultra-resilient roads. A story where simplicity, sustainability, and local wisdom come together to rewrite the future of infrastructure. In southern India, the weather isn't divided into 4 mild seasons. Instead, it's a relentless cycle of extremes where torrential rains and scorching heat take turns damaging both daily life and infrastructure. During the monsoon season, powerful winds carry massive amounts of rain, sometimes up to 3,000 millimeters, dumping it directly onto the roads. Floodwater erodes the concrete, washes away the soil beneath, and slowly destroys the road from the inside out. When the rains pass, the heat takes over. Summer temperatures often reach 45 degrees Celsius, causing asphalt to soften, expand, and crack under stress. The constant movement breaks the surface apart. Over time, materials degrade, roads fail faster, and everyday travel becomes risky and unpredictable. This isn't just a question of bad roads, it's a problem that affects how people live, move, and survive. Faced with this harsh reality, Indian engineers came to a hard truth. Traditional solutions like asphalt and chemical stabilizers were too expensive and simply not made for this climate. So they started looking elsewhere. And they found their answer in an unlikely place, a material once thought to be worthless farm waste, used only as compost: coconut fiber. So why choose coconut fiber? At the microscopic level, coir is a natural mesh of cellulose and lignin, which gives it both flexibility and strength. Its tensile strength can reach up to 175 megapascals, comparable to mild steel. More importantly, it does not decompose in wet environments and is resistant to microbial attack. That means it can be buried underground for decades and still remain intact. When woven into geotextile fabric, coconut fiber locks soil particles firmly in place while still allowing water to pass through. This creates a kind of biological armor that protects the road from internal erosion, something that asphalt can never do. It's not only effective but also extremely affordable. It's just 1/4,600 of a traditional concrete road, making it one of the most promising materials for low-cost, sustainable infrastructure. Of course, producing coconut fiber geotextiles takes several steps, and everything starts with one simple thing: the coconut. Most coconuts in India are grown in the southern states, where over 19 billion coconuts are harvested each year, forming a major part of the local economy. The coconut tree is known for one unique trait: nothing goes to waste. Every part of the fruit is put to use. The water is bottled, the oil becomes a beauty product, and the milk is exported worldwide. The husk, usually used as fertilizer in farming, takes center stage in this project. But harvesting coconuts isn't easy or safe. Coconuts are typically harvested about a year after forming, when the husk has matured enough to extract fiber. Unlike other crops that are cut once a season, coconut trees bear fruit all year round, so harvesting must be done the traditional way. Skilled workers climb trees up to 10 meters high, using machetes to cut down entire bunches of coconuts, letting them fall freely to the ground. Each coconut can weigh more than 3 kilograms. If it lands on a rock or exposed tree root, the shell may crack, reducing the quality of the fruit and the fiber inside. After harvesting, the coconuts are transported to a processing site where the husks are separated. Each coconut is split open by hand, and the fibrous outer layer is peeled away from the hard shell using a sharpened wooden or metal spike. The process may seem simple, but it demands both precision and physical endurance. A skilled worker can process 500 to 1,000 coconuts per day. The fibrous husk, which makes up 35 to 45% of the coconut's total weight, contains the valuable coir fibers. These are often called biological steel due to their impressive tensile strength, resistance to rot, and durability far beyond other natural materials. Once separated, the husks are spread out in the sun to dry for 2 to 4 weeks, depending on weather conditions. The goal is to reduce the moisture content from 65% down to 15%, making the fibers softer, easier to extract, and less likely to grow mold. Most facilities handle about 2 tons of husk per day, a scale that shows how surprisingly cost-effective this process can be. When the husks are fully dried, they're loaded onto a conveyor belt and sent into a fiber extraction machine, also known as a decorticator. Inside, rotating blades and compression rollers shred the husk and pull the fibers apart in a continuous motion. The rough fibers are then passed through a barrel screener, which filters out dust and short fragments. What remains are long, clean, and evenly sized fibers, the ideal raw material for making geotextile fabric. To finish the preparation, the fibers are sun-dried again for another 3 to 7 days, bringing the moisture content below 5%. This final drying step helps the fibers stay light, mold-resistant, and structurally stable, ready for long-term storage and weaving. Once the fibers are fully sun-dried and meet quality standards, they are sent to the spinning section. Here, the fibers are sorted by length and twisted into uniform yarns with high tensile strength. This twisting process reinforces the natural fiber structure, creating strong, durable yarns without the need for any chemical additives. The yarns are then bundled and transferred to the weaving area. Vertical strands are stretched tightly to form the backbone of the fabric. Then, horizontal yarns are woven through using guided needles, creating a tight, interlocking mesh. The loom maintains consistent spacing between each weave, ensuring the fabric can both hold soil particles and allow water to pass through, a critical feature for erosion control. The finished fabric has a rough texture, but offers exceptionally high tensile strength. Each roll is carefully inspected for thickness, weave consistency, and knot quality before leaving the factory. The final product is a roll of geotextile fabric, 1 meter wide and tens of meters long, tightly rolled like a layer of natural armor. On average, 100 kilograms of coconut fiber can produce 250 to 300 meters of geotextile fabric, 1 meter wide, at a cost of just $1.20 to $1.80 per meter. Before shipment, each roll is tested for strength, thickness, and uniformity. Even a small weak point in the weave could compromise performance on a real construction site. Once all the raw materials are ready, the construction process begins, and it starts fixing the ground beneath our feet. Most of these roads are built in areas with soft, unstable soil, old rice paddies, riverbanks, or clay-heavy rural land. Without treatment, this kind of ground would collapse under the weight of even a small truck. So engineers begin by compacting the soil using 8 to 10-ton vibratory rollers, pressing it to reach 95% modified Proctor density, the minimum standard for load-bearing performance. To make sure the ground is completely flat and level, they use laser leveling tools, ensuring no more than 2 centimeters of deviation across every 10 meters. This precise grading is critical. Even the best geotextile won't work unless the base is stable. Next comes the real magic, the coconut fiber geotextile. Rolls of natural fabric, 1 to 1.2 meters wide, are unfurled along the roadbed. Workers fix them in place using U-shaped steel pins or sharpened bamboo stakes, driven 20 to 30 centimeters into the ground every 1.5 to 2 meters. The result is a tight, anchored mesh that won't shift under pressure. What's truly remarkable is how simple this part of the process is. With just 3 to 5 workers, it's possible to lay down 100 to 150 meters of fabric in a single day, even in difficult terrain. Labor costs are low, and the flexibility of this method makes it ideal for remote rural zones where heavy machinery might struggle to reach. With the geotextile in place, engineers begin building a protective structure on top, a multi-layered armor that distributes weight, drains water, and resists erosion. First, they spread a 10-15 centimeters layer of fine gravel, 8-20 millimeters in size. This protects the fabric from sharp pressure points and spreads out the weight of vehicles. A 10-ton roller compacts this layer while also setting a 2% cross slope so water naturally drains to the sides of the road. Then, a cushion layer is added, sand or blended soil, depending on availability. In some areas, a mix of soil, fly ash, and cement is used to boost strength and surface smoothness. This step creates a softer transition between the gravel base and the final surface layer. Finally, a 10-20 centimeters layer of crushed stone is added. This acts as the primary load-bearing layer, able to support the weight of small trucks while also serving as a drainage path. Water seeps through but doesn't pool underneath, preventing internal erosion. Thanks to this structure, coconut fiber roads can support vehicles up to 12 tons, with a lifespan of 10 to 15 years, even in regions with heavy rain and high heat. In Kerala, some trial roads have lasted over 18 years, requiring only basic maintenance. Unlike traditional paved roads in the US, Europe, or the Middle East, which typically cost between $60 and $150 per meter, a road made from coir in India costs only between $1.50 and $2.20 per meter, including all materials, labor, transportation, and construction. But it's not just the price that makes this system stand out, it's the sustainability. There are no toxic chemicals, no construction waste, and no high electricity demands. Each stretch of road is a living example of green engineering, powered entirely by local agricultural resources. And that's not all. This construction method also creates thousands of rural jobs, from coconut harvesting and fiber extraction to weaving and road building. It forms a closed-loop economy that strengthens communities while reducing dependence on imported technologies. Perhaps this is what the developed world needs to relearn. You don't always need high-tech materials to build lasting infrastructure. Sometimes, the most sustainable solution is the one that's been growing on trees all along. Alongside the geotextile fabric used in road construction, the journey of the coconut continues. From its water to the flesh, down to the thinnest outer skin, every part of the coconut finds its place in a carefully crafted economic system shaped by Indian ingenuity and a culture of deep resourcefulness. This is not just recycling. It's a closed-loop strategy where every part is used, nothing is discarded, and nature is treated as a partner. It's a zero-waste philosophy driven by intelligence, tradition, and a quiet respect for the natural world. Coconut water is considered the purest and most valuable part of the coconut. Immediately after harvesting, each coconut is drilled with a small hole to extract the water. A simple process, but requiring strict sterile conditions to avoid contamination, ensure quality for use, and qualify for production or export. India is currently the world's third largest producer and exporter of coconuts, with an industry worth over $500 million annually. The coconut water is then directly transferred to a rapid cooling system at 4 degrees Celsius, preserving its natural enzymes and essential minerals. At the processing plant, the coconut water undergoes microbiological filtration, surface oil removal, and short-cycle sterilization using UHT, ultra-high temperature technology. Then, it is hermetically sealed in multi-layer paper cartons on an automated production line capable of processing up to 6,000 packages per hour, completely isolating the liquid from light and air to maintain its freshness. During the coconut water extraction process, the nutrient-rich white pulp with its natural aroma becomes the main ingredient for the next product, virgin coconut oil. The brown outer shell is removed first. Then, the white pulp is washed with high-pressure water jets, pureed, and cold-pressed using a mechanical press. This cold pressing method helps preserve the molecular structure of the oil, retaining its flavor, aroma, and nutritional value. Different from chemically refined coconut oil, it does not require the use of harsh additives. In this process, the oil is simply filtered through industrial filter paper, then bottled in high-quality glass or PET bottles, all under sterile conditions to ensure purity. This is not just a premium beauty or health product. It is a symbol of a clean, smart, and sustainable economy, a business that respects both nature and quality. With just a small change in processing, the coconut flesh can be turned into coconut milk. The mixture is slowly cooked at 60-70 degrees Celsius for 30-45 minutes, then sterilized in steel cans at 120 degrees Celsius. To preserve its natural flavor and nutrients, producers use high-pressure processing, HPP, at 600 megapascals, which kills bacteria without affecting quality. Alternatively, the same coconut meat can be shredded into 2-3 millimeter slices and made into coconut candy. After simmering in sugar for about an hour, the slices are gently dried at 60-70 degrees Celsius and packed in airtight zip-seal bags. The result is a product that meets export standards while preserving the soul of a traditional local treat. In a world where concrete, asphalt, and chemicals have become the standard for modern infrastructure, India has chosen a different path, transforming what the world once called waste into roads that last. No billion-dollar machines, no imported technologies, just coconuts growing in the backyard powering an entire green industry that is sustainable, self-sufficient, and waste-free to the very last fiber. If you believe the world has something to learn from this approach, let us know in the comments below. And don't forget to subscribe to Massive Minds for more real-world solutions that could reshape the future of our planet.